Hello, and welcome to the OpelX podcast, bringing you candid and open discussions about all things in the power electronics world.
This show is a part of the Open Power Electronics Network. Visit us online at opelex.net. That's opelex.net for show notes, articles, tutorials, and a whole lot more.
My name is Abhijit Kshirsagar. Currently, I am a professor at the Indian Institute of Technology, Dharwad, where I teach and conduct research in the Electrical Engineering Department.
And I am Lalit Patnaik. Currently, I am a fellow at CERN, Geneva, where I work in the Beams department designing power supplies.
Lalit and I were colleagues at the Indian Institute of Science, Bangalore, where we both completed our MTech and PhD degrees in the Power Electronics Group at the Department of Electronic Systems Engineering, DESE.
Over the coming weeks, we will be talking to leading academics, industry professionals, entrepreneurs, and other leaders in power electronics and allied fields. We hope you will find this useful and entertaining. So sit back and enjoy. Hello everyone and welcome to the next episode of the OpelX podcast. Today we have Dr. Jemimah Akiror, who currently works at the Uganda Electricity Generation Company in Kampala. And before this, she was at Concordia University in Canada, where she completed her PhD. And welcome, Jemimah. Could you give us a more elaborate introduction?
Hello, everyone. My name is Jemimah Akiror. I usually like to go by my names without the titles of doctor, but whenever it's possible, I use doctor. I live in Uganda. I work for Uganda Electricity Generation Company Limited. It's the generation company owned by the state in Uganda. And our business is really generation. The electricity sector was split into three parastatals, one that does generation, another that does transmission, another that does distribution. So I work for the one that does generation. Before I joined this company, I was studying. I was doing my PhD in Canada. I was doing a sandwich program, which was part-time study at Concordia University in Montreal, Canada. I was partly working at Hydro-Quebec Research Institute as a student researcher on one of their projects, which was increasing the hydro generation capacity of generators, the old generators that they had. So basically, the project was about how can we harness modeling and simulation and prototyping to help us improve or increase the life of hydro generators. Mm-hmm. Prior to that, I was still in Concordia as well, where I did my MSc, my master's. And my master's was in a very specific field in materials, which was core losses in ferromagnetic material. Mm-hmm. And before that, I was in Uganda, where I did my bachelor's at Makerere University, one of the prestigious universities actually in the whole of Uganda. At some point, it was, I think, in the whole of East Africa. Mm-hmm. It was one of the very prestigious universities, but it's still in the running, although we still have a long way to go. I did electrical engineering. That was my bachelor's degree. At the moment, like I mentioned, I'm working for UEGCL as an asset manager, where my current role really entails planning for our assets, visibly demonstrating how we can manage risk. As a company, we have assets that have been there since 1954 and others which were just commissioned in 2019. So being able to plan for these assets in terms of the decisions we make, decisions on operations and maintenance, decisions of investment, considering the full life cycle of the plant, really. So my work involves, having more intentional approach to decision making, to managing risk, sustainability of the different assets that we have. And this really is in alignment with an international standard for asset management.
Can you tell us a little bit about undergrad education in Uganda and your perspectives of how it compares to your experience in Canada or North America?
That's a very good question. Our undergrad program in Makerere, at least for all engineering fields, is 4 years. It's a 4-year program. in Concordia, it's same. It's also 4 years. But what I found, what was very different with the way it's done in Concordia was they took more of a project approach and more like an applications approach, which I think is very good. What I mean by this is you spend a lot of time understanding the concepts and then applying them in a project compared to where you are studying the science of whatever the phenomenon is. So I find that, they call it a Bachelor of Science in Engineering. So I guess that's where the emphasis is. I would definitely prefer a mix of both kinds of teaching styles.
Interesting. So are you saying that your undergrad you did more of applying the science, sort of understanding the concept, and then there would be an exam? How was it?
Yes, exactly. So it was very highly theory oriented. Of course, in our 4th year, we all had big projects that spanned 2 semesters. Mm-hmm. And in the final semester, you had to do your presentation that would mark you passing. So usually it was a project that required you to do some sort of prototype at the end. But what I found in Concordia, almost every course did have a project. And if it was a course that had both undergrad and grad students, you would find those projects are done by either 2 grad students or 1 grad student. And while if it's undergrads doing a project, it's maybe 4 undergrads doing 1 project. So I found incorporating that aspect of having the students to actually, do something, build something, think of something, analyze something. Mm-hmm. It really brought the knowledge to life, or brought the science to life, or whatever it is you were studying. Yeah.
Very nice. Could you maybe elaborate on 1 or 2 projects or some of your internships or industry experiences through your time in Canada? Yeah.
So while I was in Canada, I didn't have an opportunity to do an internship. What I did was that part-time working at Hydro-Quebec. Mm-hmm. But I'll mention a bit about the projects in relation to what I was talking about.
Sure.
So during my master's program, I did 4 courses. And in each of those 4 courses, I had to do a project. Mm-hmm. During my PhD, same thing. I did 4 courses, and in each of those 4 courses, I had to do a project. So, for example, I had a course which was called Renewable or Energy Resources. So, at the end of the course, taking the knowledge that you had, you were asked to propose medium and long-term energy strategies that your country would can adopt, and you propose this with evidence. Of course, you do some analysis, you do some some background work, come up with figures and all the different aspects of it. Renewables, why do you choose that particular renewables, putting in mind that the entire process. For example, if it is wind, don't just look at the wind turbine, look at the manufacturing process of the wind turbine and how that contributes to, emission of gases and things like that. And then bring it full circle in terms of, okay, if it's a renewable that you're replacing, while it might have some issues at disposal time or at manufacturing, overall, this is the benefit you get versus using coal. And so with that background information, you're able to propose what recommendations you would give. And I remember I did a recommendation for East Africa. What are some of the medium and, long-term energy solutions we could look at. I did a course called Hybrid Electric Vehicles, and in that course, my project was something to do with judging the efficiency of small electric cars versus big electric cars, and, what kind of motor should it have? Is it an induction machine, or should it have a permanent magnet machine? And, depending on different drive cycles, what is the efficiency of using these cars? So things like that. So the whole idea was you study the theory, you have the engineering equations and understand the dynamics, and then you have a project to do, and come up and apply everything you've learned.
Yeah, it was interesting that you mentioned the energy or resources required to create the system, the entire life cycle costing, as you mentioned.
Yes.
I think you must be finding it very useful in your current position, right? Because that's part of your responsibility now.
Yes. So it's interesting how a lot of things come together somehow and become useful to you even in the future. Because at the moment, before we make any with the program that we have on asset management that we are trying to develop according to the standards, is before you make a decision on a certain asset, you have to really look at it in over the entire full life cycle of that asset.
Right.
You know, the small change you would make, what impact does it have in terms of you deriving the value from your asset over its life cycle? So it's no longer, we need it, buy it, and that's it. It's more like, okay, when we buy it, what is it going to change? What is its impact? And then how long will we have it? And then when we are done with it and we want to dispose it, how much is it going to cost us? So are the costs comparable with our value? I think that those projects were quite helpful to me in retrospect.
Yeah, I think you were also going to talk about a second project. You were mentioning about the work at the IREC.
Yes. So I joined the Research Center of Hydro-Quebec under a supervisor called Dr. Areski Markov. So in the projects, the way it works in Hydro-Quebec Research Institute is they do a lot of research projects from different research fields. There are people working on batteries and, transmission lines and things like that. So the particular project where I was, they mostly focus on generators, the whole unit, both the turbine and the generating unit. And specifically, at the moment when I joined, they had launched a very big project, which was to increase the life of their machines. How can they increase the life of their machines? When I joined the project had been running for a few years before I joined. And basically, you have different specialists looking at different things. For example, if you have a certain shape of a turbine, what can you do to that shape that will increase its life a little bit more? Mm-hmm. If you have a generator, if you want to do some sort of refurbishment on the generator, maybe the generator was commissioned in the 1960s or 1970s. And right now you're thinking, how can I extend some more life out of this generator before I completely discard it? Or as I plan on getting some more new generators. So when you're doing refurbishment, what can you change in your generator that could help you get either increase the life of that generator or increase the power output of that generator? Mm-hmm. So mine, I was specifically looking at trying to understand the electromagnetic material that is used in these generators, the cores, studying the characteristics of how the flux moves in these cores. And if we understand how the flux moves in these cores and understand the associated losses in the cores, then we will be able to analyze different kinds of materials and, recommend that if we use this material, we'll have less losses, and therefore it means we can get more, power out of it versus if we use this material. So next time you think of doing a refurbishment on the core, please use this material, not this one. Mm-hmm. So my work, I was studying specifically core losses, trying to understand how core losses are distributed in the generators and what are some of those factors that, influence the losses in the generators, and trying to quantify them for different kinds of materials that are used.
If I'm not wrong, I think I heard that Hydro-Quebec went ahead and used some of the results that or some of the recommendations that you made to increase the, let's say, capacity of the generators.
I don't know how far it went. It's those projects, when they roll out, they're about, 8 years, 10 years. Mm-hmm. And everything that every researcher does is only a tiny bit of the rest of the big pie. Mm-hmm. So while I might have been working on the core, maybe at the moment they thought maybe the winding is the one that needs a little bit more help at the moment. So maybe let's go with so-and-so's work. But by the time I left Hydro-Quebec, I left them with a test bench. We prototyped a test bench that they can use to test whatever kind of material they want to test, specifically for iron losses, rotational core losses. Mm-hmm. If they ever decided to go any other route, they had the test bench, they could test it and they'll be able to quantify the losses. There were models and there was a prototype, so they're able to really quantify and make a decision thereafter. Mm-hmm. I need to follow up with my former supervisor if anything came out of the work thereafter. Uh-huh. Yes.
One thing I do remember when I visited Concordia University a couple of years back, Sudarshan was a postdoc there at that time, Sudarshan Karthik, who is now professor at IIST. And he showed me the setup for the rotational core loss measurement.
Yes.
And it was impressive. And now I come to see the person, or at least have a conversation over Zoom with the same person. So it's nice.
Yes. Oh, yeah. I think we were about 3 or 4 students that worked on rotational core losses. There was someone whom I found working on rotational core losses. It was called Natir. I don't know if you saw his test bench. It was the one that had a lot of whole back effect setup.
Mm-hmm.
Then John Wanjiku, we worked with him as well. I think we've written a paper with John, and I've written, I think, 2 papers with John, and I've written one with Sudarshan. Sudarshan jumped into it as well. He really helped us figure out a feedback loop in designing the system. Yes.
Mm-hmm.
So that was quite something.
It's interesting that you have a bachelor's in electrical, then you have a master's in, you said it was material sciences, right? Or materials engineering.
Yes.
And then you're applying that back in your PhD, which is electrical for a power application. So I think, this sort of resonates with what Professor Umanand, who's the PhD advisor for Lalit and myself, he used to say there are no domains in engineering, there are no domain boundaries, and you need to know whatever it takes.
Yeah.
So I think this is an interesting example of seeing that in your career trajectory, where you're coming from a materials approach and then applying it to electrical engineering.
Yes.
So do you think this magnetics work that you have done in materials, do you think that applies to other domains, let's say transformers, design of power converters, and other things other than just machines?
Yes. So basically the core you have in a transformer is the same core that you would have in a generator. It's the same core you would have in any other machines that you have that basically uses the principle of electromagnetics to function. There are things you really need to have in this core, and the properties that you have that you require in a core in a transformer are the same properties you have or you require when you use that same core in a smaller machine, or in an induction machine, or whatever kind of machine you're looking at.
Mm-hmm.
So to answer your question, yes, definitely there's an application of what we did for those particular ones. For a long time, for example, in transformers, you basically just have some formula that we use if you want to know what the core losses are in a transformer.
Yep.
But let's say my work was mostly to go deeper into that formula and see, what are those other things. And that formula makes some assumptions that, the flux inside the transformer, the flux inside the machine is basically pulsating flux.
Mm-hmm.
But we found in our work that actually the flux, even in the transformer that should only have pulsating flux, it does have some areas where the flux is rotational. And so that formula needs somehow to be tweaked to give you those particular losses associated with rotational flux.
It's interesting.
So, having talked about your Canadian experiences, it's very interesting to find out what is it that made you go back to Uganda after some years that you spent in Canada. Could you talk us through that?
Yeah, that's a very good question. For me, my biggest reason for coming back was family. I had been, during my study, I was away for about 6 years, because I did my master's for 2 years and then my PhD for about 4.5 years. So for me, the biggest drive was family. I think I'd missed family a lot. Being the last of 7 children and used to being around family, I think at some point I felt it was time to go home. And also, I never really got used to the winters in Quebec. They are very brutal, very cold.
Nobody does.
So, and also, I think from the very beginning, I did have a mindset when I was leaving Uganda to go study. I did feel I belonged back home, and that at home is where I can do something.
Interesting.
I can contribute to make our country better, or to make my contribution. So I knew even if I had gone away, at some point I had a resolve that I would be back.
Excellent.
Yes.
So when you came back to Uganda, did you have a career path or a job already lined up, or did you move and then decide, start looking for positions?
Yes.
Can you just tell us? Because moving internationally is a nightmare.
Yes.
To put it mildly, having done it myself twice.
Yes.
And I can imagine not having some certainty on the other end of that is just even worse. So did you move back after you already had a position, or did you move back and then start looking? How was that process?
So that's a very good question, and I think it's one of the questions that faces a lot of students that go abroad to travel. At some point during your study or when you're about to finish, that's the big question. Should I go back? Should I stay? Or if I go back, what's there for me? If I stay, will I get a job here? And I don't think there is a straight answer for that one. I think at the end of the day, it's how do you see your life? What do you want to do with your life, and where do you think you have the better opportunity to do it? So for me, when I decided to come back after my PhD, I didn't have a job offer. I didn't have any job prospects, but I thought to myself, I can't fail to get something to do. I'm sure if worst case came to the worst, I would probably go volunteer and teach at the university, just do something as I look for an opportunity to open up. But when I got back home, I was actually at home for about, I got back in December. I started working, I think, around March, I think April or March. And I got the job, I think, at the beginning of March. So I had about 2 months of looking for work. And I was lucky that the first job that I got, it was being a maintenance manager at a power plant. At the time, the power plant was just under construction. So as members of the maintenance and operations team, our work was to oversee or supervise the commissioning process and also the construction process. At the time when they're doing the different installations, you need to be there to know what are some of the possible things that will give you issues when you start actual operations, and when you start like actual maintenance. You need to have that background project information to make your work a bit easier. So no, I didn't have a job, so I just came back blind, and lucky for me, something worked out.
I think with your confidence and with your, skill set and your academic qualifications, I don't think there's any doubt that you would have found a position.
Yes.
But do you think that being in Canada gave you that confidence that, you can, I'll definitely find something when I move back? Do you think being overseas gave you that confidence?
Yes, I think so. Somehow it must have developed a bit of my confidence. And then also sometimes, when people see, you studied abroad, people kind of tend to listen to you a bit more. But I must say in Uganda, right now the atmosphere is a bit changing. But before, if you have a PhD, somehow you are resigned to teaching or going to the university, not the industry. Somehow that is like an automatic. Everybody thinks you should go and teach. In fact, if you apply for a job, sometimes they'll tell you you're overqualified for this job, or, why aren't you teaching? Why do you want to come and work here? Why don't you go and, teach at Makerere or any other university around? So I think the atmosphere is a bit changing a while. But before that, I think people that came before me, maybe 2 years or 3 years before I came back, and if they had doctorates, they really had a hard time finding work because of this mentality. So somehow the mentality that research and, PhD is limited for university, it doesn't apply in industry, or it doesn't work for the industry, something like that. But I think that is changing a lot because different companies are now embracing research as a good component of what they do to improve what kind of services they give. Yeah.
Since you mentioned about let's say the industry changing its outlook on how it looks at PhDs. Could you tell us something about the work culture in general in your company, or how you basically foster new ideas? How do you manage projects? Something about the general culture, work culture.
So UGCL, one of our core values is innovation. So it's really encouraged. Actually, it's recognized. If you came up with a new idea or a new way of doing things, or, a solution nobody had thought of, and, it worked, at the end of the, performance cycle, you would be recognized with either, a gift, a trip, or something. Like, you're recognized, you're given something of value to appreciate you for your efforts towards innovation. Part of our mandate at UEGCL includes research and development, especially in the hydroelectric field. So our CEO, being a PhD as well, is really very strong towards innovation and coming up with new ideas and, finding better ways of doing things and overcoming different challenges. So in company-wise, I think the fact that it is included in our core values, and also it's one of the things when you're going through your appraisal, it's one of the things they look forward to. I mean, you are welcomed to mention what you contributed during the year. How did you contribute? Did you, show people a better way to do things? Did you invent something that people can now use and they're benefiting from it? And the funny thing is that, however, simple or straightforward the innovation could look like, as long as it has made people's lives better, you're recognized for it. And so in a way, it really helps and encourages people to come up with new ideas. Another thing is we are also encouraged to participate in international conferences, especially conferences on hydropower. So when you hear hydro, 2020, I think this year a team was supposed to come to India for this conference. And people are always, every year, encouraged to write papers. If you write a paper into a hydro conference and it's accepted, you're sponsored to go for the trip. So you go present your paper in addition with other things. So that is the way it's encouraged, I think, research and new ideas within the company. Yeah.
Actually, talking of innovation and research, one more thing that is sort of very important as ever, but more important now, is the role of women. And you being a woman leader in the area of engineering and the power sector, what are your thoughts on that aspect of how the engineering field as a whole is dealing with the issue?
I think women should be encouraged to join engineering. And I think some women are naturally gifted, when it comes to the engineering fields, mathematics and physics and applied sciences. I think the challenges that most women face is, once you get into the field, is the field supportive of women? One of the challenges that most women face is, you join the field, you're excited and, you can do what the guy can do. But the challenges are, at some point in your life, you're going to be a wife and then you're going to be a mother. So sometimes you have to make that choice between, staying another 2 hours at office versus going home to pick your kid and things like that. So I think companies and the society in general can do a lot to support the girl child or the women into engineering fields. I cannot tell you how many women I know that, have been in engineering actively, but at some point in their lives, they settle for something like, management is easier. It's easy. You just make, schedules, tell people to do the work and you come and reevaluate versus actually being the one doing the work, So you find a lot of girls, even within the different companies, someone joins as an electrical engineer, very passionate. And, as you go along with them over the couple of years, things begin to change and they divert to other, softer fields, support roles and things like that. So I think a lot needs to be done to encourage women to do it. And it's not from the perspective of the brain that they don't like it, but more like making the environment more conducive to support them to follow the profession, but at the same time, be able to give their best, on other spheres of life. Yes.
Basically, we need a lot of changes in the system.
Yes.
To be able to support women and respect their differences with respect to men.
Yeah, it's very nice that you mentioned a very sort of a complete picture of what the issues are, and it's not that equality is just making everything equal is not really just the right solution.
Yes.
Can you just is there something that in your experience from Canada is there something that you learned that you plan to apply to make to say encourage young female engineers in your sphere?
Yes.
Or just in your life, is there something that in your experience you found that you would like to share with our listeners? Because our listeners are going to be, of course, young engineers, they're going to be faculty, they're going to be industry experts. So is there something that you would like to share with them?
Yeah, I think the first to the women especially, you can be an engineer, you can be a mother, you can be a wife. I think you shouldn't sacrifice your profession for the rest of the spheres of life. I think the challenge is finding a balance between all of them. I don't think you should give up one for the other. I think you can find something that works. Whatever works for you can easily, you have to find something that works for you. And then I think for the rest of the communities to be a little bit more understanding, a little bit more appreciative of this fact that while we all have responsibilities, there are certain extra roles that women, kind of take on that people can be conscious of. I'll give an example. In Canada, in Montreal, for example, when a lady has a baby, she stays at home for almost a year. So by the time she goes back to work, her child is 1 year old.
Yep.
In some countries like Uganda, for example, by the time you go back to work, your baby is only 3 months old. So you can imagine the difference, between the two. While a lady engineer, for example, in Quebec, is going to go back, ready for work because she knows at least the first year of their child is, well catered for and they can concentrate on work. In other countries, you go back to work and, half of your mind is at work, the half is, back home. So I think it's a big challenge that a lot of countries need to, open our minds towards. And I am grateful because in Uganda, a lot of that is beginning to change as well. So while you may go back to work, when the baby is 3 months, these days companies can allow you to have, 2 or 3 extra hours off per day if you're still nursing your child. So until I think the child is about 6 months to 8 months, which I think is a very good incentive. So, if I have to work my 8 hours and maybe I have 3 hours, so I have 5 hours, those 5 hours are completely for your work. And then, in the other extra 3 hours, you can attend to other issues. The advice I would like to give everybody there is really just to be mindful of that. We all have sisters, so we all have mothers. I think we can really identify and spouses. A lot of people eventually get married as well, so it's something you would see, especially if you married somebody that is actively working. Yes.
Very, very nice answer there. Thank you. Can you talk a little bit about what your day-to-day role in your current work is? What is it that what are the key challenges that you're trying to address in your present company and your present role, and what are the sort of big implications of what you're trying to?
Yes.
Of course, whatever is public, we don't want to know any privileged or proprietary information.
Yes.
But anything that's public or
So as a company, our company began in 2004. 2003 actually, and then we began work in 2004. Before that, the electricity sector in Uganda was bundled. So it was called UEB, Uganda Electricity Board.
Right.
So basically it had all the different sections: generation, transmission, distribution, all bundled up together. And then in 2003 it was disbundled to generation, transmission and distribution. So it was only until around 2013, about 2014, 2013, that generation finally got an opportunity to increase its mandate. At the time when we were disbundled, what we did was they took all our assets and they were concessioned out to another company to run them for us. So basically we're just doing concession monitoring. But that was until about 10 years later, 2014, 2015, 2014, when now our mandate expanded to actually acquiring and then developing hydropower stations and then actually operating and running them ourselves instead of concessioning them. So that brought with it a lot of pressure for us to do our things according to standard, international standard, for different reasons. One, for sustainability, to be able to keep our assets top notch and things like that, bring in the money. But the biggest is really to get the value that we get, out of having our things to standard. Things like, being able to have grants if your things are up to standard and so on and so forth. So what I do on a day-to-day, like I mentioned before, is one of the standards we as a company would like to align ourselves to is the asset management standard, which is either PAS 55 or ISO 55000. So this standard basically just outlines how an organization would decide to run their processes, or how they can plan every activity and their procedures and their organizational systems and structures to be able to generate value from their assets. And you as a company can define what value means to you, but then what systems and procedures and, what intentional things are you going to do to make sure that you derive this value from your assets? My big task is, what kind of systems as a company should we do? Well, there are so many systems to do. Yep. Which ones can we prioritize?
Yep.
Yes.
You mentioned sustainability as one of the key sort of drivers for the company.
Yes.
And I think Uganda is one of the world leaders in hydropower penetration, right?
Yes.
So you have a majority of the national electricity coming from hydro, which is, the cleanest and, most mature renewable technology that's available right now.
Yes.
I think it's really nice that the focus is on sustainability. So can you sort of parse how the value from your asset sort of encompasses that sustainability, or let's say carbon free, or how do you capture that component in your value calculations?
Yeah. So when you have an asset, like I mentioned, especially hydro assets really have this thing where they can last for long if they're taken care of very well.
Right.
And while if you plan, for example, to have an asset for 50 years, maybe you wouldn't take care of it as much. But if you want it to last 100 years, maybe, 20 years, 50 years over and above its design life, then you have to make a lot of calculated decisions. For example, when do you change out that filter? At what point do you change it out? If you change out that filter, how much is it going to cost you now versus if you wait another 3 days or another maintenance cycle to do it? And what is the impact of it versus the whole system as a whole? How that affects the whole system. So in terms of sustainability, we look at it, our theme at UGCL is generating for generations. So we try to make our decisions such that even when we are not here and our generation is gone, the assets should still remain, or they should still be functional. So when you decide to invest in an asset, or when you decide to do a certain type of maintenance activity on an asset, you have that at the back of your mind. What are the implications of what I'm doing on the life of this particular asset? Yes.
Good point.
So somehow we try to project that into the future as well.
Could you tell us a little bit about how do you think students who want to get into this field of power generation and, commercial power production, do you think that current students are ready? Do you think they're lacking some skills? Do you think there's something that the undergraduate or master's programs should do better so that students are better prepared for industrial jobs? And of course, this applies both to jobs in Uganda, worldwide, whatever you feel. Just sort of touching on, there are a lot of buzzwords in education these days, right? So students want to get into, software, or they want to do something that seems more flashy. But do you think that there are any other skills that that are needed for students to be able to work in these fields as well?
Yeah, so power field, really, I think it's open to anyone who would really want to do it and get into it. For me, I would think if you want to get into the industry, the biggest skill, which is a soft skill, is, I would call it, attitude. Because I think every industry does have entry-level position jobs for different fields. Even engineering, as an electrical engineer, you can join an organization. Like, for example, at our company, we have, we have internship where people come and go back to school. But we also have, after they have graduated, we have programs where you come and work with us for 2 years, and then you can get a position. If a position opens up, you apply for it and you can get it. So why am I saying attitude is the biggest thing that I think? I know by the time a student does engineering or any other, some of those courses, is they're already good at it. They understand the basic concepts. They're probably good at math and, physics and problem solving, and that's why they're doing engineering. So I think on the knowledge side, most of the time we have that covered, and that information these days, you can find whatever you need on the internet and you can learn or teach yourself something. And a lot of companies offer opportunities for you to join in entry level, where they'll literally hold your hand and teach you what they do and how they do it, and you get better at everything that they're doing. I think the biggest problem, or the biggest thing that no one can teach you, is attitude. What do I mean by attitude is, what is your willingness to learn? What is, how do you see problems? When you're presented with a problem, what is your approach of problem solving? How do you see problems? Are they a bother to you, or is it a good challenge, a welcome challenge for you to solve? Are you somebody that can easily be taught something new, and, you're eager to learn and things like that? So for me, I think we should try as much as possible, especially in the engineering fields, to try to better our soft skills as well, which includes, especially if you want to work in the industry. I don't know about research yet, but I think in the industry, even when you go to an interview, the reason you're in the interview is because your papers already say you are good. You are bright enough to take the position. You have the skills. And now when they interview you, they are looking for your attitude. They're looking for how you present yourself. They're looking for how you communicate. They're looking for if you are a kind of person people can work with, if you have good attitudes towards other people, and, how you'll be able to work with other people who are doing support roles, people who will be working with you. So I hope that universities can try to embed some of this soft skill learning in the engineering program. So when the engineer has finished their 4 years, 5 years, 7 years, they come out with that aspect of the soft skills also well covered. And I think it plays a very big role in the industry. Yeah.
Very pertinent remarks. I think that is a very good observation from someone who's worked in academia for a while and then now moved to industry. I think that's a very good remark. And I remember when I once attempted a job interview, basically the only reason that they had an extended interview was they said, I think you'll be a good fit for the team.
Exactly.
So is this person a good fit?
Yes.
In the team? Can they work with the other people? That was like a make or break decision for many managers.
Yes.
And of course, having a good manager is part of that equation.
Exactly.
So I think we've covered a range of topics, Jemimah, from deep research to industry experiences, both in North America, East Africa. It's been really nice to have you.
Thank you.
Providing some very fresh perspectives and answers to questions that, we honestly didn't even know we had those questions. So it's been really nice to talk to you.
Yeah, it was excellent. Yeah.
We, at the OpelX project, we value all these inputs, and I'm sure our listeners will find this very valuable.
Thank you so much for having me.
Thank you very much. We look forward to watching your progress in your career, and we wish you all the very best. Thank you.
Thank you very much, and thank you so much for having me.
Thanks. Bye-bye.
Thank you, Jemimah.